My name's Ethan Tremblay. I'm the basketball coach here at Swag Central High School. I'm also the geometry teacher. Today we're going to be teaching the kids about the 5 proofs in geometry.
Ethan, you missed it.
No, I didn't. What if you make everything seem so dark?
Yeah, you really missed it.
Geometry proof number 1.
What's wrong?
I can't figure out their offense, Peter.
It's easy, it's just a balanced offense.
No, Peter, it's not. It's not a balanced offense.
Ethan, yes it is. It's
No, Peter.
Aren't you the geometry teacher?
That is besides the point, Peter. That is why do you make everything seem so dark?
I'm gonna prove this to you through proofs. This is a proof type number 1. Watch this.
Jeez.
Picture this as the 3-point line. There's their 1 and 2 guards, there's their 3 and 4, and their 5. We're given that AE is equal to DE, and BE is equal to CE. Or congruent, actually. Now we need to prove that AEB is congruent to DEC. So we're given that AE is congruent to DE and BE is congruent to CE. So now we need to find another congruence property so that we can prove that these triangles are equal. So all we have to do is say that angle 1 is congruent to angle 2. This is due to the vertical angles property. So now we have 3 congruent parts, and we can prove that these triangles are congruent by using the side angle side congruence property, using the lines 1, 2, and 3.
Number 2. I don't understand how this works. Look, they've got their point guard bringing across here, alright? Then they've got their 4 here, their 5 here running the baseline, and they got their 2 and their 3 spotting up in the corners. I don't understand how this works though. How can we defend that?
It's really simple. They just put the 5 in the middle, right in the middle, as in a midpoint, to spread out the defense.
Good way to look at it.
I don't know why don't you understand this?
It's just confusing.
Alright, I'll show you through proof, once again.
But you act as if I'm stupid or something. How does this work, Peter?
Well, there are 5 guys right here, their 2 and 3 is right here, and their 4 is right here. The point guard is just up here, but that's irrelevant. So we're given that AC is equal to BC, and M is the midpoint of AB. We have to prove that triangle ACM is congruent to triangle BCM. So we start out with AC is congruent to BC, and that's given, and M is the midpoint of AB, which is also given. So now we got to show that AM is congruent to MB. That would be the definition of a midpoint. So, oh, there's the bell. Well, CM is congruent to CM, which would be the reflexive property. So now we have 3 congruent parts. So we can show that triangle ACM is congruent to triangle BCM. That would be the side-side-side congruence property, which is using lines 1, 3, and 4. So that's how their offense works.
Proof number 3. Okay.
What's wrong now?
Okay, Peter. I didn't want to come down to this. Certainly not this early. But I really did not figure out their defense. I get it. What is going on? No, what is going on? No, I'm asking you a question. What is going on here, Peter? Seriously. It's ridiculous.
It's a 2-1-2.
Because he's dead, Peter.
It's a 2-1-2 full court press. And pretty much they're just trying to trap you so that you create a turnover. It's pretty much spread out evenly throughout the floor, so if you want me to, I can show you through geometry how they run this press.
There you go. You're trying to make me look like an idiot again.
I just want to show you.
Just because I'm a geometry.
Nobody's watching. It's not like this is a TV show.
Okay, you have a point. Hurry though. One of these students walking in.
So we're given that angle ABC is congruent to the measure of angle DCB. And we're also given that line AB is congruent to, or is equal to DC. So we've got those two given. And so next we need to prove that angle ABC is congruent to angle DCB. So we just use the definition of congruent segments. So our next move would be to prove that segment AB is congruent to segment DC, which is just using the definition of congruent segments. So the move after that, we have two congruent parts. We need three. So we just got to find something that the two triangles share, which would be this line right here, CB. So CB is congruent to CB using the reflexive property. So we now have three congruent parts, and we can say that triangle ABC is congruent to triangle DCB by using the side angle side congruence property and using lines 3, 4, and 5.
Proof number 4.
Okay, does anybody have any questions over problem type number 4?
I do.
Of course you do. What are you, a girl or something?
No.
So what do you have a problem with?
I just don't understand it. I do.
Okay. Well, first, start out with DR perpendicular to AG.
Ethan, you're wrong. You're teaching this whole class.
Stop it. Peter, stop it. Seriously.
You're teaching the whole class the wrong type of.
Peter, stop it. You're hurting my rep, okay, Peter?
You're teaching them wrong. I don't care about your rep.
There are ladies watching me, okay?
I don't.
She's legitimate, okay? Found her on Craigslist. She's watching me. She's a really cute lady.
But anyway, you're teaching her the wrong type of proof.
Not in front of Ethan Jr. Okay, seriously, stop.
No,
Whatever.
just leave. Okay.
Freaking cot-headed ninny muggins.
So proof. Yeah, I don't know. Proof type 4. We're given that DR is perpendicular to AG, which means that ARD and GRD are both 90-degree angles. They're both right angles. Okay, so that's the definition of perpendicular using line 1. So we can say, using that angle DRA is congruent to angle DRG. And that is all right angles are congruent. So the next thing we want to do is we're given that RA is congruent to RG. So now we have two congruent parts for the triangles, and we need one more. So we find the side that these two triangles share, which is DR, and by using the reflexive property, we can say that DR is congruent to DR. So we now have three congruent parts to the triangles. So we can now say that DRA, this triangle, is congruent to DRG. So that will be using the side angle side factor, which is using using lines 5, 4, and 3. So, do you have any more questions?
Thank you.
No problem.
You're a lot better than the other guy.
Yeah.
Stop. I heard that. Seriously.
Just ignore.
Proof number 5. Talk about swag.
Hello class, my name is Peter Hyman, and I will be your new teacher for the rest of the year. Your old teacher, Mr. Tremblay, was fired. He hit a small child. So, we'll get on with proof type number 5. We'll start with this. We're given that AE is congruent to CD, or is equal to, and that angle A is congruent, or equal to angle C. We need to prove that triangle ABD is congruent to triangle CBE. So the first thing we need to do is put our two given statements down here, which would be AE is equal to CD and measure of angle A is equal to measure of angle C. So our next step would be AE is congruent to CD. And that is because the congruent segment property, we just take line 1 and make it congruent. After that, we want to take angle A and make it congruent to angle C. We'd be taking line 2 and using the congruent angle property. So there we have two things right there that we've taken these two and made them congruent. So our next step would be to make we need to find another side. So if we erase these two lines in the middle, we can show that this triangle would be an isosceles triangle, considering that angle A is congruent to angle C. So when you have two equal angles in a triangle, that means it's an isosceles. When you have an isosceles triangle, you can say that two of the sides are the same as well. So we can prove that AB is congruent to CB by saying isosceles triangle property. And that's using line 4 because of these congruent angles. So the next thing we need to do, we need to find this side and make it congruent to this side. So the first thing is we're going to use the addition property. Say that CE is made up of CD plus DE. And then AD is made up of AE plus ED. And then we're going to substitute using line 1 and line 7 AD for CD, or AE for CD. So if you look, we would have AD equals AE plus ED. And so after you do that, AE equals CD plus DE, you can now say that AD and CE are equal because they both equal AE plus ED. So we now have that AD is equal to CE, and we need to prove that AD is congruent to CE, which is just using the congruent segment property. So we now have three congruent parts, and we just need to show that these two triangles are equal. So triangle ABD would be congruent to triangle CBE, and that's using the side angle side property. And we're using lines 4, 5, and 10. So that's about all for proof type number 5. Does anybody have any questions?
What are you, a girl or something?